Good day everyone, this is Rivera, your speaker for today. The subject of my talk will be about geology and non-renewable mineral resources, particularly about rocks and minerals, as well as the rock cycle. Minerals are naturally occurring solid inorganic substances. They have a regular repeating arrangement of atoms and molecules. It is a naturally occurring homogeneous solid with a definite chemical composition and a highly ordered atomic arrangement. It is usually formed by inorganic processes. There are several thousand known mineral species, about 100 of which constitute the major mineral components of rocks. These are the so-called rock-forming minerals. By its definition as a homogeneous solid, a mineral is composed of a single solid substance of uniform composition that cannot be physically separated into simpler chemical compounds. Because of this feature, minerals are classified as crystalline solids. Under favorable conditions, crystalline materials may express their ordered internal framework by a well-developed external form, often referred to as crystal form or morphology. Minerals can be described and classified according to their physical properties such as their crystal structure and shape, hardness, luster, color, translucency, cleavage, density, as well as how they react to substances such as acids or magnets. It is the properties that makes them useful for important things such as manufacturing. Rocks. They form within the earth and make up a large part of our planet. Earth's crust is made up of many different types of rocks. Rocks are so common that most of us take them for granted, cursing when we hit them with the garden hoe or taking advantage of them to drive in tent pegs or summer camping trips. But that is how regular people describe rock. In science, what is rock? To geologists, a rock is a natural substance composed of solid crystals of different minerals that have been fused together into a solid lump. The minerals may or may not have been formed at the same time. What matters is that natural processes glued them all together. Over long periods of time, many rocks change shape and type as they are transformed by wind, water, pressure, and heat. All rocks contain one or more minerals. In geology, it is explained as the naturally occurring and coherent aggregate of one or more minerals. Such aggregates constitute the basic unit of which the solid earth is composed and typically form recognizable and mappable volumes. Rocks are commonly divided into three classes according to the processes that resulted in their formation. These classes are igneous rocks, which have solidified from molten material called magma; sedimentary rocks, those consisting of fragments derived from pre-existing rocks; and metamorphic rocks, which have been derived from either igneous or sedimentary rocks under conditions that caused changes in mineralogical composition, texture, and internal structure. To further understand these classes, we will tackle them one by one. First is the igneous rock. Igneous rocks are those that solidify from magma, a molten mixture of rock-forming minerals and usually volatiles such as gases and steam. Since their constituent minerals are crystallized form for molten material, igneous rocks are formed at high temperatures. Igneous rocks are subdivided into two categories: intrusive and extrusive, in which case the cooling molten material is called lava. Second, we have sedimentary rock. Sedimentary rocks are those that are deposited and lithified at the Earth's surface with the assistance of running water, wind, ice, or living organisms. Most are deposited from the land surface to the bottoms of lakes, rivers, and oceans. Sedimentary rocks are generally stratified. They have layering. Layers may be distinguished by differences in color, particle size, type of cement, or internal arrangement. And lastly, the metamorphic rock. Metamorphic rocks are those formed by changes in pre-existing rocks under the influence of high temperature, pressure, and chemically active solutions. The changes can be chemical and physical in character. Metamorphic rocks are often formed by processes deep within the earth that produce new minerals, textures, and crystal structures. The recrystallization that takes place does so essentially in the solid state rather than by complete remelting, and can be aided by ductile deformation and the presence of interstitial fluids such as water. Now that we have discussed about rocks and minerals, our next topic will be about the rock cycle. The rock cycle is a group of changes. The rock cycle is a concept used to explain how the three basic rock types are related and how Earth processes over geologic time change a rock from one type into another. Each rock type is altered when it is forced out of its equilibrium conditions. So this is my best illustration of the rock cycle. As you can see, igneous rock forms when magma cools and makes crystals. Magma is a hot liquid made of melted minerals. The minerals can form crystals when they cool. Igneous rock can form underground where the magma cools slowly, or igneous rock can form above the ground where the magma cools quickly. When it pours out on Earth's surface, magma is called lava. Yes, the same liquid rock matter that you can see coming out of volcanoes. On Earth's surface, wind and water can break rock into pieces. They can also carry rock pieces to another place. Usually, the rock pieces called sediments drop from the wind or water to make a layer. The layer can be buried under the other layers of sediments. After a long time, the sediments can be cemented together to make sedimentary rock. In this way, igneous rock can become sedimentary rock. All rock can be heated, but where does the heat come from? Inside Earth, there is heat from pressure. Just put your hands together very hard and feel the heat. There is heat from friction. Rub your hands together and feel the heat. There is also heat from radioactive decay. It is the process that gives us nuclear power plants that makes electricity. So, what does the heat do to the rock? It bakes the rock. Baked rock does not melt, but it does change. It forms crystals. If it has crystals already, it forms larger crystals. Because this rock changes, it is called metamorphic. Remember that a caterpillar changes to become a butterfly? That change is called metamorphosis. Metamorphosis can occur in rock when they are heated to 300 up to 700 degrees Celsius. When Earth's tectonic plates move around, they produce heat. When they collide, they build mountains and metamorphose the rock. The rock cycle continues. Mountains made of metamorphic rock can be broken up and washed away by streams. New sediments from these mountains can make new sedimentary rock. The rock cycle never stops. That ends my report. Once again, this is Rivera. Thank you for your patience and attention. Thank you for watching. Have a good day.